review for the test. And let's see here. Did I raise my hand? Didn't mean to raise my hand. No, it's not raised. Okay. Okay, let's see what I got here. My entire screen. Make that wide. I haven't done this in a long time. I've been in the classroom the whole time, but I'm doing it on here. And my last classes I did in front of my. Anyway, so the topic for today is angles and radians. Angles and radians. And I got a ruler here. Perfect. Nice. Topic is angles and radians. Our assignment. What is our assignment? What is our assignment? We have here is, remember trying to do a test review. Hopefully you guys did your check your understanding. We had 3 of them this week. A lot of you haven't been doing it. Get zeros if you don't do your check your understanding. You have a check your understanding today. Check your understanding is today. Okay, make sure you check your understanding. We had one on Monday. We had one Tuesday. Tomorrow we just review. And then Friday we have the test. And we have assignment 7.4, 8.1, and 8.2 due on Friday. Okay, our assignment is 422, 5 through 29 odd. Okay, so let's go ahead and talk about angles. Okay, so you guys all know that we have angles and they look like so. Like it's an angle. Flink. Flink. You don't have to write this down. I'm just drawing a picture of an angle, right? There's an angle. Boom. You don't have to write it down. You don't have to write it down. Unless you don't know, you can write this. What is this part of the angle called right there? What is that? What is that part of the angle called? Let's go with, let's see. Am I recording? I am recording. You guys can see me recording. Let's just pick someone randomly. Let's see. Abraham, what is that part of the angle called right there that I pointed right there?
Can I guess?
Yeah.
The point?
It is not the butt. Did you say the butt?
The point. The point.
Very inappropriate. I'm just joking. Yeah, it is the point. But
oh, it is?
Well, this is a point, but it's not the point. We specifically call that the vertex. Have you heard of that before, Abraham?
Yeah.
Okay, cool. Now, this we call these many things, but you guys don't, again, you don't need to write that down. You don't need to write down, but that's what it's called. Now, this is called the leg or the side or the ray, and same with this over here. Now, we're specifically going to talk about angles, though, on the coordinate plane. So if you want, you could start writing this out. Let's see. Oh. On the coordinate plane right here. So I don't know if this will help you, but this is something new. Now, this is a coordinate plane. Of course, we have here the x-axis and the y-axis. Now, the angles that we're going to work with on the coordinate plane are going to be right here where the vertex is on the origin. Okay? And we call that, when the vertex is on the origin, we call that the standard position. That is the standard position. Now, we have this right here. On the standard position, we have one of the sides of the angle, or the leg of the angle right here. We call this side the initial side. The initial side. Everything we work with, the initial side will always be on the x-axis. Okay? Now, the angle will open up And we have this part right here. Okay. Now this side that is not on the x-axis, this is called the terminal side. That is the terminal side. Okay. Now, of course, no, we're not going to work with protractors or anything, but I can see that this angle opens up. You know, from here to here is 90 degrees. This is from here to here is 90 degrees. So this angle has to be bigger than 90 degrees. I don't know exactly what it is, but let's say it is, let's say it's 100 degrees. That angle from there to there would be 100 degrees. Imagine if this was like a clock and you open it up, right? Now the clock can keep spinning. And I'm going to draw another one. Let's draw another angle. I'm going to draw these quick, so they're going to be quick and sloppy. So let's say I have another angle right here. My initial side's right here. And let's say my terminal side goes over here, right here and right here. Well, guess what? How many degrees would that angle be, right? Give it a go. Let's go with Alonzo. How many degrees would that angle be there?
180.
Yeah, 180. 180 degrees. Now let's ignore this part. Let's say the angle goes here, right? Now it goes from here to here. Okay, so now that angle, right, it's got to be bigger than 180, right? So let's say it's another, I don't know, 15 degrees, 25 degrees. Let's say it's 225 degrees. So the angle can be over 180, and we'll call that 225 degrees. So guess what? From here to here is 90 degrees, 90 degrees. From here to here is 180 degrees. From here all the way around to here, that's going to be 270 degrees. 90 plus 90 plus 90. And so what that would look like, let's do that in green. 270-degree angle. Can you see with all these angles here? You have an angle here, and then that angle would be here. It'd go all the way around. That would be a 270-degree angle. Even though it looks like a 90-degree angle, we're opening it all the way on 270. So that's where the terminal side. And then you can always go all the way back around to 360. Now, couple of things here. I'm still drawing these angles. You guys can draw, or you can just watch. You just have to understand the concept. So I don't know if you need to draw it to understand the concept, or if you get it. Now, sometimes the angle can go like this. Boop, boop. Now, we are going in this direction. But let's say this. Whoops, sorry. Can you see that now? Okay, watch carefully. This is going to be weird. Right? So imagine if it hands a clock and it just opens and opens and opens, right? You can see it's like opening, 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 opening like that, right? What if it goes like this? Watch what I do here. What if the angle opens? Watch, watch, watch. Goes around, goes around, goes around. Keep going, keep going, keep going. And it keeps going. And let's say it stops right here. And let's say from here to here, let's say from here to here is, I don't know, let's make an easy number. Let's say it's 60 degrees. Okay, that's not the angle measure. That's 60 degrees. How big would that green angle be if I go open up and all the way around and then there again? How big is that angle? Okay, how big is that angle? I'll give you a second to think about it. How big is that angle? All right, Bryson, tell me how big that angle is.
Would that be 420?
How'd you get that?
I added 360 plus 60.
That's 100% correct. Bryson saw that we went all the way, got to 360, so it's at least 360 plus another 60. So that total angle is 420 degrees. And then you could keep going. Now, you could imagine that there are actually two angles here. One is 420. See, the green one's 420. And then imagine if I had an orange one on top of the green one that went like this, orange, to here, orange. And so I have the green angle that goes twice. I have the orange angle that just goes like that. That'll be two angles that are there. What are my measures of those two angles? Those are called so you need to know this name. They're called coterminal angles. This little angle sign, coterminal angles. So I have the green angle, which is 60 degrees. And then I'm the orange angle. And then I have the green angle, which is 420 degrees. Those are coterminal angles. And how can you find coterminal angles? Well, you just add or subtract 360. So since I'm on coterminal angles, actually, hold that thought with the coterminal angles. I want to show you one more thing. Coterminal angles. But we're going to go back to coterminal angles in a second. Now, let's say I have an angle. Instead of going in that direction, instead of going, okay, watch carefully. Instead of going this way, let's say we go this way. Notice I'm spinning in the opposite direction. Okay? Now, let's say the distance between here and here is 30 degrees. What is the measure of that angle as we record it? What do you think the measure of that angle would be as we record it? Carlos, what would the measure of that angle be? Going backwards.
30?
You are sort of correct, but you need to make one little change. If we're going in the what?
Oh, I'm not sure.
You make one little change if we're going in the opposite direction. It's not 30 degrees. Opposite. Does that help you with that hint, Carlos? Or am I just confused?
You're just confusing me.
No way, Carlos. Even if I confuse you, you can't say I could. Look at this. I need to make sure you understand. Even if I confuse you, you can't even say that I confuse you because I am an amazing teacher. It's not my fault. It's your fault. Carlos, right?
Yes, Sensei. Mm-hmm.
Okay. I'm just joking. I'm sorry. Carlos, I don't know what came over me. I'm sorry I confused. I just get defensive. You're right. It's my fault. Carlos, I apologize.
That's okay, Sensei.
Okay. All right. Well, let me try to make myself more clear. Does anyone else know what I was saying? Okay. Anyone help Carlos out? How about you, Kevin? If we're going the opposite, it's not 30 degrees. What's the opposite?
30?
Negative 30. That was my hint, Carlos. I tried to make you say negative 30 instead of 30 degrees. Whenever we go backwards, we go negative 30 degrees. All right. Now, so I can go, let me do one more. If I go like this, doop, doop, and I go here is my angle, and here is my angle. Whoops, I know I'm totally off screen here. Let me get on screen. I go from here to here. Well, I'm going in the negative direction. What would the measure of that angle be there, that green angle? Let's go with Dennis White.
Would it be negative 30 again?
Well, from here to here, what does this look like? 30 is more like this, right? Because it's smaller.
60?
But I'm
Or 90. 90. Negative
90. There you go. Yes. It's negative 90 degrees. And it's negative. You got it right. And then, but if I went in this direction, then that would be a 270-degree angle. In fact, we can have both of them there right on top of each other, and those would be coterminal angles. Okay, those would be coterminal angles. So let's get back to coterminal angles since we had negative and positive. Let's get back to the coterminal angles because that's going to be on your homework problems, and then we'll be almost done here. We got to talk about radians. Oh my gosh. Didn't Godzilla fight a monster called Radian or something? What if there was a Godzilla? Like, where would you run to? I have no idea. If Godzilla really existed. Okay. This is what they're going to ask you in the book. Let's say we have, go back to 60-degree angles. Let's say this angle is 60 degrees. Okay? They're going to ask you to list two coterminal angles that are the same as 60 degrees. So basically, what's another angle that I'd go all the way around and go boop, or I can go in this direction, boop. They want a positive and a negative, right? So if I went this way and I went another, let's say right here, the way you do is you go 360 degrees that way. So all you do to find the two coterminal angles, or two angles that equal 60 degrees, is you add 360 and you subtract 360. So let's say I have a 60-degree angle. Well, to get a coterminal angle, what do? Add 360. 420 is coterminal to 60, or I subtract 360. You'd have to do 360 from 60, but that would be, if I'm going this way, negative 300 degrees. So you add 360 or you subtract 360. That's how you find coterminal angles. Are there any questions on coterminal angles? Let's take a look at the homework. Okay, number 5. Remember the homework's 5 through, what was it? 5 through, you guys see it? 5 through 29. So draw an angle. So you just have to draw the angles. Draw 110. Draw negative 900. I'll do number 7. I'll draw a negative 900-degree angle. So number 7. 110, it doesn't have to be exact. In the standard, remember, standard position means that the origin is on, the vertex is in the origin. So we want one that's negative 900 degrees. Okay, well, no problemo. It's number 7. You guys do number 5 on your own. But let's say I want negative 900 degrees. And so, what would it do? Negative 900. Hey, boo-boo. Okay, remember, negative goes in this direction. So let's take a look at what we got. Where would it be? Here we go. You guys watching? There's 360. Got to keep going in the negative direction. I spin around twice. How many degrees is that? 720. But now how many more degrees do I need to get? So 900 minus 720 is 180 degrees. So you want to go 180 degrees more. Okay, to get negative 900. Well, there's 90. And then 180 would be right there. And so that would be negative 900 degrees. It's got to stop right there. So my vertex is there. And let's draw the rest. Be like that. And then that would be negative 900 degrees. You got to show the spins. All right, so that's 5 and 7. You guys just draw the 110. Where would 110 be, right? 90, 110, right? That would be like somewhere over here, right? So just draw that. Okay. Anyway, I'm moving on. So that'd be negative 900. Let's write it here. Negative 900 degrees. Okay, that's 7. You guys do 5 on your own. Are there any questions? I'm going to move on. Any questions? No. 5, 4, 3, 2, 1. Boom. Okay. Find one positive and one negative angle that are coterminal. Remember coterminal? You add 360 to 70, or you subtract 360, right? This one you add 360 or you subtract. That's all you got to do. Just add 360 or subtract 360. Are there any questions on 9 and 11? Okay. Let's do 13 through 19. Okay, so this is completely new. So you might want to take notes on this. They're asking us to convert degrees into radians and radians into degrees. Convert degrees into radians and radians into degrees. Okay? So all we're doing here is it's kind of like when they say convert inches into feet, right? You can measure with inches, you can measure with feet. It's just, you know that there's 12 inches in a foot, and that's how you figure out if the inches are the feet or the feet are into the inches. Just like radians and degrees. Now, we always measure angles in degrees, but from now on, we're going to measure them also in radians. Okay, and we're going to do that when we do trigonometry, when we do graphing trigonometry. So how big is an angle? Like how big is a 90-degree angle in radians? How big is a 70-degree angle in radians, right? Just like you say, how many inches are in 30 feet, right? Just like that. That's what we're doing with radians and degrees. The same thing to do with inches and feet, or feet and yards, or milliliters and ounces. It's fluid ounces, right? Right? Or pounds and ounces, right? It's just a conversion factor. So what we have to figure out, how many radians are in a degree and how many degrees are in radians. Okay, so let's go ahead and do it. Okay, I think I'm sharing. Now here in degrees, I'm going to draw the best circle that I can. This is the best I can draw. Here's the best circle I can draw. Yeah, that's all right. Okay. Now let's say the center of the circle is here. And to go all the way around the circle, that is 360 degrees. Okay? How many radians is 360 degrees? Now, this is how they figure it out. If you want to, you can, but I'll tell you when you have to write something down. So, what they did is they said, hey, let's take this circle and let's take the radius, and let's say the radius is equal to 1 unit. 1. Is it feet, inches? It's just 1 unit. This is a measure of 1. What is the length of the circumference of the circle if this is equal to 1? How far is it? How big is it from here to here? Someone tell me how to figure out the circumference of a circle. You can look it up. I'm going to call on you. I'll give you a second to look it up if you want. What is the circumference of a circle equal to? The circumference of a circle. What is it equal to? Circumference is equal to what? C is equal to what? I'm going to call on one of you. I'm going to give you guys like 20 seconds to figure it out. What is the circumference of a circle? I'm going to call on one of you. Emma, what is this? How do you solve for the circumference of a circle?
You 2 times pi times radius.
Very good. 2 times pi times the radius, or pi times the diameter, but we have the radius. Very good, Emma. So the circumference of the circle, if the radius is 1, is C equals 2 pi times the radius, which is 1. This is how they figured out radians. This is how they did it. 2 times pi times 1. The circumference of this circle is 2 pi. That's what 2 pi times 1 is. So they said, hey, all the way around the circle is 360 degrees. It is also 2 pi. And then they decided to call those radians. So 360 degrees is equal to 2 pi radians. But they simplified it. So yes, write this down now, Abraham. Write that down. And let's simplify it. 360 degrees is equal to 2 pi. And what we need to do is, let's get rid of the 2 by dividing by 2. 360 divided by 2 is 180 degrees. 2 pi divided by 2 is pi. And so 180 degrees, this is your conversion factor, is equal to pi radians. And so, in order to convert to degrees, we're going to use a ratio with the numerator of 180 degrees in the numerator and pi in the denominator. If they say change it to degrees, put degrees on top. If they say change it to radians, convert to radians, guess what? You put pi on top because that's my radians. You put the radians on top. They say, hey, convert to radians, put radians on top. They say convert to degrees, put degrees on top. Now I know what you're thinking. Sensei, we still don't know how to do it. What do you mean by putting it on top? Well, write those down first, and then let's do a problem, shall we? Usually when we're going to go so far, radians is like in a fraction, and degrees is degrees. So let's look at the homework problem. Usually in radians, it looks like this. See this? This is radians, pi over 9 radians. It's like a reduced fraction with pi over it. 3 pi over 4 radians. It's usually, again, a fraction, a reduced fraction with pi in it. So here's what they want us to do. In exercise 13 through 20, convert degree measures to radians. Okay. Or radians measures to degrees. So I'm going to do 13 and 17 with you guys. 13 is 40 degrees. 17 is pi over 9. Okay, here we go. Convert this into radians. Well, which one am I going to use? Well, since the radians are on top, I do that. And you just go times pi over 180 degrees. And you guys remember how to multiply fractions? You multiply the numerator times the numerator and the denominator times the denominator. Okay? But guess what? See the degrees? You have degrees in the numerator, degrees in the denominator. Those are going to cancel out. And the 0 is going to cancel out too. Can do that, reduce it. Then it says 4 times pi is 4 pi. 1 times 18 is 18. Can I reduce it anymore? Yes, they're both divisible by 2. 4 divided by 2 is 2 pi. 18 divided by 2 is 9. So 40 degrees is equal to 2 pi over 9 radians. Now, to convert this to degrees, well, guess what? I want it to degrees, so I use this one where the degrees are in the numerator. And multiply by 180 degrees over pi. Am I going too fast? Jackson, am I going too fast?
Yes.
Okay, I'll pause. Do you have any questions, Jackson?
No, I'm good.
Okay. Anyone else have any questions while we pause?
Wait, did you cross the zeros out? That's how you got 4 and 18?
Yeah,
Oh, okay.
because they reduced. Basically what I'm doing here, you did 40 pi over 180, right? 40 times pi is 40 pi. 180 times 1 is 180. Now I can reduce these. These are both divisible by 10. And that initially makes it 4 pi over 18. I just basically divided by 10. But instead of doing that, I just went flink, flink. I crossed them out. All right, Jackson, you good?
Yeah.
All right. Are you off the bus?
Yeah, I'm home now on my computer.
All right. Let's see. Is your camera's still off though? Let's see. Mara, are you with me or am I good? Can I keep going?
Yeah, you can keep going.
Okay. So Mara, look at this one now. What do you think I'm going to do here? I want to convert pi over 9 into degrees. So I use this because the degrees are on top. How would you simplify this, Mara?
I'm not sure.
Okay, well, can I ask you this? Would it make sense? Since these are in the top and the bottom, I can cross those out.
Oh, yeah.
And then this is going to be equal to 1. 1 times 180 is 180 degrees. 9 times 1 is 9. Did that make sense, Mara?
Yeah, it does.
Okay, so what would I do next to simplify that?
You would divide 180 by 9.
Let's do it, which would be, and don't forget your degrees, 20 degrees. And that's all you got to do. So the main thing is you have to know which one of these to use, okay? You got to know which one of those to use. All right, are there any questions? I think we have no questions. Okay, last one. Open it. Okay, you're gonna match these 23. That's pretty straightforward. Match. Which one's 600 degrees? You can see, hey, this one's over 360. I don't know which one. You know what I mean? You guys can match those. That one looks like 600 right there. No, this is negative. Notice in that direction, it's a negative angle. Okay, but you guys can do that. Now let's look at 27, modeling with mathematics. Okay, the observation deck of a building forms a sector. So a sector, this is a key word. This word sector means it's a part of a circle. Notice here, this is part of the circle. What part of the circle is that? If the circle was a pie, what fraction of the pie do I have here? If this is 90 degrees, what fraction of the pie would that be? Let's go with Sam. What do you got there? What fraction of the pie is this, Sam?
1/4,
Yeah, how'd you get that?
because it's 90 degrees.
Yeah, 90. There's 490 degrees and 360. A full circle is 360. 90 plus 90 plus 90 plus 90 is 360, or 360 divided by 4 is 90, or 90 times 4 is 360, okay? So the question is, find the length of the safety rail and the area of the deck. So we want the length of the safety rail, and we want this area here. Well, Sam just said this is 1/4 of the circle. So if I figure out if this was a full circle, I could figure out, if I find out what the whole circle is, then I could figure out 1/4 of it by dividing by 4. That's basically it. So let's go ahead. I'm going to draw the picture, and then I'll do the length of the fence, and then I'll let you guys do the area. Same idea. So this is 10 yards, 10 yards, and this is 90 degrees. Here we go. Okay. So this right here is the fence. Remember, the length of the fence has to do with the circumference of the circle. So if I was able to find the full circumference of a circle with a radius of 10, that's a shrunk down version, then I should be able to figure this out by dividing by 4. So the circumference of this circle is, remember to talk about this, is 2 pi times the radius, or circumference is 2 pi times 10. The circumference of the full circle is 20 pi yards. But what would the length of this be? If this is, the whole thing's 20 pi, what would the length of that be? Okay, let's go with Bink. Thomas Servin. Gotta fix your camera, dude.
Yeah.
What would the length of this be?
Wouldn't that be? Hold on.
What are you doing? Thomas, what are you doing?
Looking at my notes.
Wait, did you hear what I've been saying or no?
Yes.
Let me repeat. Okay, do you know that this is a miniature version of this? So if I was to take this out, this would be like a little flink of it. Can you see that?
Yeah.
Like I zoomed in and I zoomed that out?
Yeah.
Right? Do you remember if this is 90 degrees, what fraction of a circle would this be?
1/4 of the circle.
Yes. Now, if this is the full circle, and all the way around is 20 pi from here to here, how much would this be?
I don't know.
Stay with me.
Okay.
Thomas, stay with me, okay? Let's see if someone else can help. Samantha, can you help Devin out?
Can you repeat the question, please?
Someone tell me so we can get out of here. I want someone to tell.
I'll tell you.
All right, Jackson, tell Thomas and Samantha.
5.
How did you get that, though? You got to tell them how you got that.
So the circumference is 20, and that's only a fourth of the circle. So 20 divided by 4.
Yeah, it's fourth of the circle. Thomas, you get that?
Yeah.
If the whole thing is 20 pi and this is a fourth of it, then you do 20 divided by 4. And my answer is going to be 5 pi. Now, to find the area, we got to find the area of this whole circle and then divide that by 4 too. By the way, the area of a circle is pi r squared. Pi times the radius squared, and then you get a fourth of that. I'll let you guys figure that out on your own. Are there any questions? No questions? Can clean up shop? What's that? Nathaniel, I got a question for you.
Yeah.
Do you feel enlightened? Did I open your eyes? Do you know more about life because of me today?
Yeah.
Yes. That's all I'm asking. Ethan, how about you? Did I open your mind today?
Yes.
Yes. Yes. Dennis, did you learn anything today besides my class? Did you learn anything in your other classes?
No, only you.
Yes! That's what I'm talking about. I make your high school worth it. That's what I do. For all of you. It's worth it because of the sensei. If I was just a regular teacher, I'd have you call me Mr. Sanchez, but I'm bigger than that. I'm the sensei. Look at me. Look at me. Look at me. That's right. I am the sensei. Who am I, Bryson?
The sensei.
Yeah! All right, you guys can go. Unless you have any questions. I love you guys. Thanks for doing it. Thanks for putting up with my insecurities where I have to make myself feel better. It's really because I'm insecure. Bye, Bryson. Bye, Samuel. I love you, Alonzo. Bye, Kevin. Bye, Brett. Bye, Carlos. Bye, Samantha. Have a good day. Bye, Emma.
I have
Bye,
a
Angel.
question.
What's up, Abraham?
Do you know what settings the calculator has to be on? Because like every time I press enter and it adds a 6 for some reason.
It says adds what?
All right, so I'm going to put.
No, wait, stop. Every
Mhm.
time you push enter, it says what?
It adds a 6 to it.
Like an error?
No, okay, so if I say 4 plus 5
Yeah.
and I press enter, you're not gonna get 9. You would get 60 because it adds a 6 to the 5, which makes it 56. So it's adding 4 plus 56 instead of 4
I've
plus 5.
never heard of that before.
Hmm.
Wait, it adds 60? What does it add?
All right, so instead of putting 4 plus 5, it puts 4 plus 56.
Oh, it adds the number 6 to the second number?
Yeah.
What kind of calculator do you got?
I got the Texas Instrument one, like the TI-30XS.
The TI
It's this one.
30XS. So what I do is I just Google it and see what. Usually, like if a student comes up to me, like obviously it'd be easier for me if we were in class together. But I'd say I'd Google. I'd go, okay. Was it a TI 30
30XS.
XS?
Mhm.
TI 30 XS. I don't know. I'd say adds 6? Maybe your calculator's. I've never heard of that though.
I mean, it has been a while since I used it, so I wouldn't be surprised if it's broken or something.
Odyssey, look here. See, I Googled it. Automatically adds a digit to end of my entry. So I do that and just like Google it. I don't know. My calculator automatically adds a 9 to my last numbers every time I add to the math. For example, I type 5 plus 6 and expect 11, but the calculator does 5 plus 69, and I get 74. The 9 button does not appear to be sticky. Did anyone answer that? 4 answers. Technical support just helped me fix the same issue. You need to reset the calculator. Press the second key followed by 0, arrow down to option 2. Yes, problem fixed. So try that.
Okay.
I don't know.
I
just Google
arrow
it.
Down to option yes. Okay. So it seems that it cleared the memory of it.
Yeah, it's going to clear it out. It's going to wipe it out. Hopefully, it didn't mess you up, but it's not like a computer. So
Oh, it's working now. Oh, okay.
So Google it next time. All right. Who's next? Let's go, ladies first. Let's go with Miley, since you're there in the school. You go next. What's up, Miley?
Check your understanding for 8.1 wasn't there. Like the last one that's there is from lesson 7.
Oh, you know what? There is no check your understanding 8.1. I think I don't even have one actually.
Oh, okay.
Shoot, let me double check that. Now that I'm remembering. Let's see. My Little Pony. Okay, let's collapse everything. Collapse. Let's do student view. We're looking at it together. Collapse all. Yeah, there isn't any. Okay, thank you. So I'll try to remind everyone about that.
Okay, thank you.
Miley. All right. Okay, who's next? Let's go with. Should we go alphabetical? I'll do. Let's go with Angel.
Hi. I just had a question of how to do 9 and 11.
On today's homework?
Yeah.
Okay. Let me look at it. Okay. 9. Okay, 9. And 11? Okay. Can I do it real quick? Or do you have a quick question? What do you want me to do? Do you want me to show you, or do you want to ask the question?
Show me, please.
Okay. So we're going to estimate when we draw it. Okay, so all we do, what do they want? 109 is 70 degrees. Okay, that's easy. So you just estimate. You don't want the exact answer. So I want it to be, where's 70 degrees? Well, you're going to draw in standard position. You're going to draw one ray right here, right? And where would 70 degrees be? Well, this is 90, right? So it'd be a little less. Just estimate. Probably right about there. And there you go.
That's it? That's all we have to do for
That's it. Okay. Now, oh, wait. Oh, no. Sorry. I was thinking of the other one. No, I'm sorry. It's easier than that. I did that wrong. Stupid teacher. Gosh darn it. Okay. 70 degrees. They want you to find a coterminal angle, one positive and one negative. So basically, we'll say this 70 degrees. Let's hear this. We'll use this picture to help us understand. That's this one, but they also want us to figure out one that goes like this. Woo! And goes right there. Okay, how big would that angle be? Or in the opposite direction, from here to here, how big would that angle be? Now, I know that's confusing to you. That might be confusing to you. Was that confusing to you? I haven't given you the answer yet, but do you kind of understand what's going on, or?
Kind of.
Okay, let me clear it up. Let me make one thing. All you have to do to get your answer is do 70 degrees plus 360 degrees. Just add them. 70 plus 360, and then you do 70 minus 360, and you'll get your two coterminal angles. So 70 plus 360 would be 430. I think that's right. So one would be 430 degrees. And 70 minus 360 would be negative 290 degrees. Whoops. So you just add and subtract 360. That's all you do. Add 360, subtract 360.
Okay, that's it. That's all.
Yep. And so same thing with this one. Add 360 to negative 125, and then add 360 to negative 125 for 11. That's all you have to do.
Okay.
All right. Okay. Anything else? I'm gonna get to Ethan.
Was yesterday's
Oh,
homework?
Ethan left. Oh, Nathaniel's there. What's that?
Was yesterday's homework every other odd or
Every
just-
other odd.
Oh, okay.
Other odd. Yeah.
And I think I had one more question.
Well, let me get to Nathaniel while you think about
Okay.
it. Nathaniel, what's up?
Hi. I couldn't find the checker understanding for today.
There is none. I made a mistake. I'm gonna have to let the class
Oh.
know. Let me know.
For yesterday's?
What?
I couldn't find the one for yesterday's and today's.
Yeah, I messed up. I was
Okay.
I was like saying I'm the best teacher, but I'm really the worst. But it's just trying to make myself feel better. So it was my mistake. I'm sorry, Nathaniel.
It's okay.
All right. Everyone's gonna be stressed out, but at least you're not gonna be stressed out about it anymore. So we have a test on Friday, don't forget. All right. All right, Angel, what's up? Did you figure it out?
Yeah. So always to turn
Bye,
degrees
Nathaniel.
to turn degrees to radians, you multiply it by pi over 180, or does that number change?
No, pi over 180.
And then for the opposite, it's 180 over pi.
Yeah, to change it to degree, whatever's like to change it to degrees, you have the degrees in the numerator. To change it to radians, you have the radians in the numerator.
Oh, okay. Yeah, that's it.
That's the way I remember it.
Yeah. Thank you, Sensei.
All right, man. I'll see you, Angel.
Bye.
All right, have a good one.